Okay, so we're going to do a solve along with me, where I am seeing this problem pretty much for the first time, and I'm going to try and solve it, and you should be trying to solve it at home as well. And yeah, you can see what my thought process is when I attempt a question for the first time. So we're trying to find what the blue area is, and we have here an annulus, which is a circle inside a circle. So I'm just going to draw the center, and I'm going to think about some radiuses. So this is, let's call this radius 1. That's the radius of the little one. And let's call this radius 2. Now, the reason I've drawn it like that is, with these questions, I'm used to thinking there might be some Pythagoras going on here, because we can draw right-angled triangles. What does that give us? Well, each of these lengths are 5. So that will give us that r1 squared plus 5 squared equals to r2. Oh, r2 squared. And wait, let's work out what we actually want to do generally. So the blue area, is going to be the whole circle. So that's going to be pi radius 2 squared, the whole circle. That's the big one, minus the small one. So that's going to be pi r1 squared, like that. And actually, what can we do here? We can factorize out the pi. And so really we have r2 squared minus r1 squared. And wait a minute. Using Pythagoras, we found this. And actually, we can just rearrange this to say that 5 squared is r2 squared minus r1 squared. And this is just this. So the blue area is in fact just pi times 5 squared, which is 25 pi. How lovely is that? So the answer to the blue area is just 25 pi. Now, this feels like one of those questions that could have been completely general for every annulus. For example, if I draw it again, or try to draw it again, and if I imagine that this length is just x, if I did the exact same thing, so this is R1, this is R2, we know that we're trying to find the shaded area A. So the area would once again just be pi times R2 squared, I mixed up the 2 and the squared, minus pi times R1 squared, which is pi times, and this is exactly the same as what we did last time, because this bit is completely general. But we also have this little Pythagoras thing going on here, where this length is x over 2. So we also have that x over 2 squared plus r1 squared equals r2 squared. Well, I'm finding that hard to do, r2 squared, which means that r2 squared minus r1 squared is always equal to just x over 2 all squared. And then I can just substitute this into this. And so the area of any annulus, if you know this tangent here, or tangent to the inner circle, the area is just going to equal to pi times x over 2 squared, which is pretty neat. So just using this formula, let's say I had this question here, where this one was, 100, we know that the shaded area A would just be pi times 100 over 2 squared, which is pi times 50 squared, which is 2500 pi. That's super neat. What a lovely question. Let me know down below in the comments if you did it differently. Either way, the answer was 25 pi.